to your Thursday evening dose of astronomy. I'm Irene Pease with the Amateur Astronomers Association in New York City. I'm going to be looking at the night sky and we're going to take some little trips. We're actually going to get a little bit further away. I just felt like getting out of town, but I'm still stuck in my Brooklyn apartment. So we're going to just visit some other galaxies, get a little less local tonight. We'll be using some different software, same as usual, actually, if you've been here before. The software that you see in the background right now is OpenSpace. It's a freeware that's available to download at openspaceproject.com. And I'm also going to be using Stellarium, which you can download at stellarium.com. So starting off tonight, we'll go ahead and take a look at the night sky from Stellarium. So here's our night sky. This is now. I always like to start now. It's just kind of like grounding. And we'll go ahead and fast forward through time a little bit. I realized I actually forgot to turn some other things off earlier. Yeah, so it's not quite dark. It's getting dark later and later. You may have noticed. That happens this time of year. It's going to keep getting dark later until the June solstice, when it'll be dark really late, and then it'll start getting dark earlier. But if we go ahead and fast forward to about 10 o'clock at night, way past my bedtime, we can see what's up in the sky. Venus is still up there. Venus is going to be up for a while yet, so get used to that. Or if you haven't seen it, you still have plenty of time to go check out Venus. It'll be setting a little bit closer, a little bit sooner after the sun over the next couple months, but it'll still be out there. So that's facing west. Our winter constellations are kind of fading into the west. And tonight I wanted to actually start looking at some of the spring and summer stuff because, yeah, seasons are happening outside. So if you ever get outside, yeah, there's stuff, there's seasons and everything. So really high in the sky tonight at 10 o'clock is a kind of familiar shape. And we're going to do this several times, so you're going to be really, really used to it and really super experts for the summer when these are, out and about if you get outside. So a lot of people probably recognize the shape of the Big Dipper, which is part of Ursa Major, the Big Bear. And there's some star hopping that we're going to use using the Big Dipper. Use the handle of the Big Dipper to Arcturus. Yeah, people actually say that. I say that all the time. You arc to Arcturus. If you follow the arc of the handle, if you're outside, it's a really big arc. Everything's bigger in the sky. So that's the bright star Arcturus, which is in this constellation Boötes. It looks kind of like an ice cream cone. More on that later. So you arc to Arcturus, and then you speed on to Spica, which is really easy here because they're labeled for you, but in the real night sky, I promise it won't have big bright labels for you. There are other apps that you can use, like Star Walk and stuff, to help you identify stars in the sky in real time. But for now, we're just going to arc to Arcturus, speed on to Spica, and if you get outside, go ahead and practice that using the handle of the Big Dipper. I wanted to zip through that because I wanted to point out this constellation, Virgo. Virgo is one of the largest constellations in the night sky, taking up the most real estate, stellar real estate, or celestial real estate. And between Virgo and Leo is really what I want to talk about. So we've talked about Leo, looking for that big kind of backwards question mark and kind of the rectangle of stars off to the east of it. So if you look between Leo and Virgo, we see not a lot. But I'm going to turn on some other fun features that Stellarium has to offer. I'm going to turn on the swirly thing. Those are deep sky objects. So some of these we may have talked about before. We have these kind of dotted yellow lines. Those are open clusters. So we've gone and visited some open clusters. We've seen the Hyades. We've seen the Pleiades. Really beautiful groups of young stars kind of hanging out together in space. Anywhere from, several dozen to a few hundred. Those are open clusters of stars. And then if we turn over towards the east, there are other yellow objects. So we have some more of those yellow dashed lines, so more open clusters. Some of these you can see with binoculars. Most of them you can't see with the unaided eye. But then there's these other yellow spots that have a little cross in them. See those crisscrossy yellow circles. Those are globular clusters. Those are the best things to look at because they're my favorite, and they're like a big ball of sparkle in the sky, which is really fabulous. So again, we're not going to look at those just yet. You can Google them, and by the time I actually get around to showing you, you'll be experts. But what I want to look at are the red circles. So I think we saw some red circles a couple weeks ago. If we look in between Leo and Virgo, nothing. Oh, there's one. There's another one. There's, oh, and then it just explodes. All those red circle, well, like they're more like ovals, not so much circles. Those are galaxies, as you probably guessed from this one that says blow dryer galaxy and Virgo galaxy, and if we come in, they can see more and more and more galaxies. Okay, so this is as you can tell, this is where there's a lot of galaxies in the sky. So if we zoom in on just any part of the sky with a telescope, most telescopes, you're not going to see that many galaxies. So we see quite a few over here. There's some here. There's some here. If we go back to maybe the eastern part of the sky, let's look back over. By Vega. That's a nice star. So let's zoom in closer and closer and closer. And I don't see any galaxies there. Wah, wah. Okay. So, there was one. If I zoom in here, there's a couple. All right. But not as many as we see in this one little corner. Okay. So, yeah, there's the Hubble Deep Field, and if you look close enough, long enough with a super big telescope, then eventually you will see gobs and gobs of galaxies any part of the sky. But we're not looking that deeply. These are galaxies that are not ridiculously far away from us. So this is kind of like a local hub of galaxies, the Virgo cluster of galaxies. And we call it the Virgo cluster because, it's near the constellation Virgo in our sky. So it's not the Leo cluster of galaxies, it's the Virgo cluster of galaxies. It's a little bit closer to Virgo, so okay, fine. So that's what I wanted to look at tonight. That's where it is in the sky. So I guess your challenge for the week, if you've been looking for Hydra, if you've been looking for Leo, go ahead and try and find Virgo in the sky. It's not the brightest constellation. Spica is a nice bright star, so if you can pick out Spica, kudos, you're on your way. But then between Spica and Leo in this region of the sky, there's lots of galaxies. And if you have a good-sized telescope in a nice dark sky, you can see a lot of them. So we'll look at some of those in OpenSpace. So buckle up, get ready to blast off. I practiced this only a little bit, and it didn't break anything. Every week I see if we can break something, because that's half the fun, is breaking stuff. Let me make sure I have on. Yes, that's where we are. Okay, OpenSpace. All right, so goodbye, Stellarium. Say hello to OpenSpace. So OpenSpace is the program that's being used, and then the data that's in here is all real data from the Digital Universe Atlas that's curated at the American Museum of Natural History. And you can download that along with Party View. You can download it with OpenSpace at their respective websites. So go to the Hayden Planetarium website or go to openspaceproject.com, and you can get access to this fabulous data set. So we're not just making stuff up. It's really out there. So I just wanted to pause before we fly super fast, super luminously away from the Earth. Here we're kind of seeing the plane of our galaxy, the Milky Way in the background there. And I think we're kind of coming over, looking down on Earth's North Pole. So what we're seeing past Earth is basically what we would call the southern sky. So this is what you would see if you were in the southern hemisphere looking out at night. And a couple things I just want to point out. There's these bright stars, so those are actually stars. I know they look a little fuzzy, that's like an open space thing. But these are not giant fuzzy stars. These are giant fuzzy spots. Those are galaxies. So those are two dwarf galaxies that are basically satellite galaxies of the Milky Way. So just like Earth has a satellite called the Moon, galaxies can have like smaller satellite galaxies, little blobby galaxies that are kind of gravitationally bound and move around them. So those are ours. Those are our satellite galaxies. The Large Magellanic Cloud is the big one, and you can probably guess what the little one is called. It's the Large Magellanic Cloud, and Bob. So no, that's the small, large and small Magellanic Clouds. So they look like clouds in the sky. The Milky Way looks more like a way of milk in the sky. That's how we name things in astronomy. It's really far out. All right, so just for fun, because I love to do this when we zoom out, I'm just going to turn on the paths of the planets so we can kind of see, oh, there's the moon. Wave to the moon. Hello, moon. Good night, moon. So we can see kind of the paths of the planets as they go around our star, the sun. That should be everybody's favorite star. That's the only reason that like we have light and heat and like plant food. Yeah, it feeds us. Like it literally, like all the energy that we have on Earth can be traced back to star energy. Almost all of it. Okay, there's like geothermal energy. Okay, whatever. But like all the, even like fossil fuels, right? That's basically like dead stuff from like a long time ago that got its energy from the sun, or ate stuff that got its energy from the sun. Anyway, okay. So yeah, so stars are neat. Like almost all of our energy is really star energy, which is kind of cool when you think about it. So there's our solar system, the outer planets. Goodbye, solar system. Oh, there's another one. Okay, and one more. Oh, okay. Now we're out past the planets. And there's actually more stuff in the solar system out past the planets. I'll have to do that sometime. But again, let's just pause and take a look at our constellations. So again, we can use those as like a marker as we move really far away. We're gonna get like super far out this week. I'm excited. So there's our little bitty solar system, right? And the Earth, you can't even see like the Earth's orbit in there. You can only see like the orbits of the outer planets. There's like, yeah, Jupiter, Saturn, Uranus, Neptune, and then like Mercury, Venus, Earth, Mars are just like scrunched in there. Someone just trust me, they're in there somewhere. And all the constellations, like the stars are so far away. So it's kind of amazing, like on a really small scale, like you crack open an atom and like compared to like the electron shell, like the nucleus is like this tiny little thing in there. It's like mostly just, empty space. And then on really large scales, if you look at the space between stars, like interstellar space is like, like mostly nothing. So it's amazing sometimes to think there's anything here at all, because, there's an awful lot of nothing in the universe. And yet there's an awful lot of stuff. So how's that work? Hey, and we have some folks in. Thanks for joining us, Micah. So Mike says works with OpenSpace, and OpenSpace is here as well. So if you have OpenSpace questions, ask those folks. They'll know more about the program than I do. So yeah, just feel free to jump in if I mess up, guys. But yeah, so out here we can start to see like, yeah, the constellation lines get more warped, but yeah, you have to get pretty far away. Like we're about like 100-ish, 100 plus light years away. So most of the stars that we see in the night sky, they're not that far. Almost all of the stars you can see in the night sky are within a few thousand light years. There's only a couple that are like more than a few thousand. I think there's one, and you have to be in a really dark sky. You can see it with the unaided eye. It's like 6,000 light years away, and that's like that's an outlier. Like literally, it's an outlier, huh? Get it? So you can see where the outliers are because they're way out there. And that's our galaxy. So I think I made like an adjustment to the galaxy earlier when I was kind of poking around with this. But that's kind of like where those constellation lines are. That's kind of like just a marker so we can see where we are in our little corner of the Milky Way galaxy. All right. So we'll just leave those on for now. And I want to take a look at some of our neighbor galaxies. So I'm starting to feel better. Like I already feel like I've stretched my legs. Like I just went for a walk around the block instead of like having been in my apartment for 5 days straight. No, I got out like 30 seconds, but yeah. Let me change one thing. I think this is it. Nope. I need that. um, okay, so we'll just move out a little bit further and look at our neighbors. So our neighbors in space are green dots. Yeah. So if you ever look up in the sky and see a green dot, that's a neighbor. Um, these are the galaxies that are part of what we call the local group, because they're local and they form a group. And again, that's how we name stuff in astronomy. So our local group, mostly dwarf galaxies. So we're definitely like the biggest, most massive thing. And I'm still trying to find. Sorry, I lost my place in my. So OpenSpace is amazing. There's so many options and this huge object tree. And I'm just gonna turn that off. I do want to show the labels so we can see the names, all the fun, exciting names of the members of our local group, because they all have names. But again, most of them are very small, like dwarf galaxies, like the Large and Small Magellanic Cloud. So there you see LMC, SMC, so Large and Small Magellanic Clouds. And then we have some other names that may look kind of familiar. So like there's Sagittarius, Decif, and there's a Sculptor and a Fornax, and okay, maybe those aren't familiar to you. But Ursa Major and Ursa Minor and Coma Berenices and Boötes, I think I mentioned that earlier today. So a lot of these are named after the constellation that they appear near in the sky. So if we look in the direction of the constellation Coma Berenices, like we would see this galaxy looking off in that direction. If we look in the direction of the constellation Draco, we'd see that little dwarf galaxy off in that direction. But these are relatively close by. And by relatively close by, I mean like not tens of millions of light years away. Only, like 10. So 10 or so million light years away. There are a couple other large galaxies that are part of our local group. I didn't practice flying by those, so we're just gonna save those again for another time. I guess I'll have to do this again. But yeah, that's our local group. So 40-ish galaxies, pretty small. So we're kind of one of the big brothers in the crowd, kind of like a leader of the pack, I guess. But that's just like one little corner of our more local or maybe less local universe. So slightly less local, we have this blue grouping. I believe that would be the group around our nearest large neighbor, Andromeda, the Andromeda Galaxy. So that's the one we're kind of on it's not so much a collision course. I like to think of it as an interaction. So remember all that space between the stars? So like if you imagine there's like a galaxy over here somewhere that has like a whole bunch of stars, but then even more space, lots of space between the stars, some gas and dust and stuff. But if those are say just a few million light years away, and they're moving towards each other, eventually they'll kind of come together, but the actual stars don't like collide, so it's not like super like violent and explosive. I mean, the gas clouds, those are big. I think we looked at those a few weeks ago. So those could do some damage. But the stars themselves almost never collide, because stars are like tiny, tiny little pinpoints in like a big giant void. But yeah, so that's a bunch of galaxies. Some of them. Yeah, that's just some of them. So let's look at a few more galaxies. I guess we don't need the labels for these. I can't see them anymore anyway. But I want to turn on the Tully galaxies. Wow! That's a lot of galaxies. And not breaking my stream, which is really exciting. So this is a lot, but this is still only about 30,000 galaxies. 30,000. So that's quite a few. It's more than our local group, clearly. And this is a set of galaxies. This is the Tully set. That extends out on the order of a few hundred few 100 million light years away. So we can like get further and further away. We're around, yeah, 10 million light years out here. So I'm checking our altitude, our altitude above Earth, 10 million light years, give or take. But out here we start to see more clumping. So like our local group was like kind of like the smattering. And then out here we have like some serious, like, wow, that's a big orange blob coming around. Like, can't miss it. Big orange blob. Okay, so not really orange, just like the local group galaxies aren't really green. If you ever see like a green thing in the sky, it's probably not like natural. It's probably like a plane or something. We don't see green stars, but that's another story we'll do. But it's a nice marker, so it definitely shows up here. So this huge orange blob of galaxies, you can probably guess what that might be. Yeah, that's that blob that we saw that was over between Leo and Virgo that we called the Virgo cluster. So we're just gonna hone in there because there's some cool stuff in there. Well, there's a lot of cool stuff all over. But yeah, so all these galaxies, this is downtown, all right? So like this is the Big Apple, and then where we are in the local group, that's that's like way out the tip of Long Island, whatever's out there, okay? Which is nice. It's pleasant. There's space, you can go outside, walk around, look up, and then this is like city central. So this whole mess of galaxies, it's about 65 million light years away from us, but it's like a swarm. So a couple of them one in particular, I wanted to pick out, and this is going to be a little bit of a test again. See if I can turn on some labels, and this is going to be a little blinding. So just shield your eyes for a minute because there's a lot of them, and holler if you can see M87. So we have an M60, there's like the 40s and stuff. There's a 64. I know there's a better way to do this, but I don't know what it is right now. So I practiced this and I found it twice earlier tonight. So third time is not going to work, obviously. But somewhere in here, I found it. I lost it. It's, wait. It's in here somewhere. All right, so there's a lot. There's a lot, and see if I can find it again. Some distracting noises. All right, I might just pick a random one and pretend that's it. So somewhere in here, M87. Oh, okay, there it is. All right, so see this dot here? This dot, M87. I move it in here. See, you're going to have to help. There's M87 right there. There's that dot. So I'll get rid of the labels. Okay. So kind of center on that dot. Woo, this one. This dot right here. This galaxy, this orange dot represents the galaxy. It's a M87. It's a big galaxy. It's far away. And that's the one, it's kind of famous, has a supermassive black hole in the center of it. So that's like really exciting. So a lot of these galaxies have supermassive black holes in the centers of them, but this one's like super massive. Like there's supermassive, and then there's like stellar mass black holes that are those are pretty neat, and they're all over the place. But the supermassive ones, those are in the centers of black holes. And then this one in M87, that's the one that we have a picture of. So it was like a year ago now. Time flies when you're sitting in your apartment in Brooklyn. It was a long time ago now, it seems, where we actually got an image of the supermassive black hole at the center of this galaxy. So like our black hole at the center of the Milky Way galaxy, we call that one Sagittarius A star because it appears in the constellation Sagittarius, and the A star, I don't know what that means, but it's about four and change million solar masses. So it's 4 million suns and then some. So that's how massive it is. This one in M87, okay, 4 million compared to 2.4 billion. So that's like 1,000 times more. It's basically 1,000 of our black hole. right? So we have like a black hole, and this is like 1,000 of those crammed into one. So that's pretty neat. I mean, 2.4 billion. I mean, our galaxy only has about 400 billion stars in it, so that's a big percentage of the mass of just our galaxy. Um, so neat, right? Supermassive black holes, and everyone likes black holes. If someone finds out that you like study astronomy and if they want to ask you about seriously three things: dark matter, dark energy, black holes, and basically the answers are we don't know, and we really don't know. Not necessarily in that order. But one other super fun thing that we can do because OpenSpace is awesome, I want to show some images. This is one of my favorite things to do with OpenSpace when I've, just had like a long day sitting in my Brooklyn apartment and I just need to kick back. I think this is the one. Yeah, that'll do. Oh, wow. Okay, that's close enough. Um, I just kind of like take a little trip outside our neighborhood, outside our galactic neighborhood, into out into the Tully. And so these are the images of a lot of these galaxies. Some of them not the actual galaxies. So like you can see here, we've used the image of the Black Eye Galaxy again and again and again. But that's okay. You kind of get the idea. So if we imagine being in this bustling city of galaxies, and these are exaggerated about 40 times, but only 40, right? I mean, that's not even 2 powers of 10. It's well close to it. But imagine like being in one of these galaxies and having your night sky not just be, the plane of the rest of your galaxy, like we have the Milky Way like zipping across our sky. And then we have like these two little smudges you can't even see from New York because they're like really far south. You can see the large and small Magellanic Clouds, like these big old fuzzy spots. There's another galaxy. We can see the Andromeda Galaxy from here. But imagine being able to look out and see like all these fuzzy spots. It'd be like making up like constellations out of the galaxies. So like think about like all those little red dots that we saw when we were like poking around between in our sky for between Leo and Virgo. Like if you had like all these little fuzzy blobs that you could connect the dots and make up pictures that were whole galaxies and not just stars. I think that'd be just really amazing. So kind of a fun thing to just think about. I'm just gonna kick that around. So where we are, we're not in the densest part of the local universe, but we're also not totally isolated. Like if you look, some of these galaxies are out here kind of really just on their onesies, with probably a much darker sky, just some stars, just stars. That's all. Want want. No galaxies to speak of. But where we are, we have the local group. We have Andromeda. We have our little dwarf, large and small Magellanic Clouds. Just kind of a neat thing. So there's a lot more to Tully, and there's even more galaxies beyond that. So we've only gone, like I said, about 65, 70 million light years from home, which the universe is big, just FYI, like really, really big. I think Douglas Adams probably said it best in Hitchhiker's Guide, which you can read because probably not a whole lot else going on. But yeah, it's a big, crazy universe. So another time we'll get further out there. I was about 30 seconds away from actually following up and doing more Mars stuff this week, but I chickened out and just really wanted to go go on a trip through the galaxies. So now we're coming in through our ridiculously exaggerated neighbors. And instead of leaving you way out on the edge of the Virgo cluster, we'll come back home, home sweet home to the Earth. So if you have questions, comments, feel free to chat. Otherwise, thanks for tuning in. I do take requests. Let me just put up my, I always forget to do this, credits. So again, I'm Irene Pease with the Amateur Astronomers Association of New York. So you can check out some of our other online events. No in-person observing right now, but we have some astrophotography meetups. We have other special interest groups. We're doing some classes. Maybe doing a class over the summer if observing still doesn't happen. And check out the OpenSpace project at openspaceproject.com. And if you're interested, also Stellarium at stellarium.com. So thanks again for joining us, and have a nice evening with your Thursday dose of astronomy, and be safe out there.